Hi students, welcome to class 9 chapter 2. Is matter around us pure?
The universe consists of matter and radiation. What is matter? The air we breathe, the food we eat, plants, animals, stones, clouds, stars, even a small drop of water or a particle of sun, everything is matter. So we can define matter, things which have mass and occupy space. Radiation, you know very well the rays of the sun, light emitted by the stars. So the universe consists of matter and radiation. What the matter is made up of? Elements, compounds, and mixtures. What are elements? The basic form of matter that cannot be broken down into simpler substances by chemical reaction is called element. What are compounds then? Two or more different elements chemically combined with one another in a fixed proportion by weight. What are mixtures? A mixture is a material made up of two or more different substances which are physically combined. Now, let me give some examples. Elements, the hydrogen, oxygen, chlorine, the metals like magnesium, aluminium, copper, silver, gold, these are all some examples for elements. Compounds, water, carbon dioxide, nitrogen dioxide, ammonia, methane, these are all some examples for compounds. Mixtures, now we are mixing a spoonful of salt or sugar in water. It forms sugar solution. So that's a example for mixture. Now what these elements, compounds and mixtures are made of? Atoms and molecules. So atom is the smallest particle of element that takes part in the chemical reaction. Group of atoms we call it as molecule.
Now let's learn what these elements are made of. They are made of same kind of atoms. For example, let's look at the element iron. Iron is made of same kind of iron atoms which are identical in shape, mass and other properties. On to your right, let's look into what an iron lattice is made of. It's made of the element iron, which is made up of atoms of iron. With a closer look using an electron microscope, we can see the arrangement of iron atoms on the scale of 2 nanometer and 1 nanometer. Let's start with learning the building blocks of chemistry, that is the elements. So far, there are a total of 118 elements. Out of that, naturally occurring elements are 90 to 94. The rest are man-made elements. Let's look into some elements we use in our daily lives. Gold represented with the symbol AU and silver represented with the symbol AG are the most common elements used in jewelry. Copper with symbol Cu and aluminum with symbol Al are mainly used in the making of electrical cables and cooking utensils. Iron with symbol Fe is used in the making of construction materials, cast iron pans and iron nails. Carbon, oxygen and hydrogen are the three most primary elements that all living things are made of. Astatine with symbol At and technetium with symbol Tc are man-made elements since they occur in very trace quantities on Earth.
Element is a basic form of matter which cannot be broken down into simpler substances by the chemical reactions. Elements are all made up of same kind of atoms. Thus, for 118 elements have been discovered. Each element is unique and has its own fascinating properties. All of the 118 elements were arranged in a table called modern periodic table. The elements are classified into metals, nonmetals, metalloids and radioactive elements. Now let's look how these elements are placed in the modern periodic table. This is the modern periodic table of the elements. 7 horizontal rows are called periods and 18 vertical columns are called groups. Now let us discuss about the 18 groups. Hydrogen is given isolated position though it is in first group. The first group elements given in red are called alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. Second group elements are called alkaline earth metals, that is beryllium, magnesium, calcium, strontium, barium and radium. First and second group represent the S block elements. Now, the 13th group starts with boron, its boron family. 14th group is the carbon family. 15th group is the nitrogen family called nitrogens. 16th group is the oxygen family called chalcogens. 17th group starts with fluorine and it is called halogens. 18th group starts with helium is called noble gases. Group 13 to 18 represent P block elements. Now on your left are the metals, on your right are the non-metals. On the zigzag line highlighted in yellow are the metalloids. Now I hope you have understood how the elements are arranged in the periodic table.
You might think Earth is a big lump of rock, hard on the outside and soft in the middle, but quite a lot of it is actually metal. What exactly is metal? Over 3/4 of the chemical elements that occur naturally on our planet are metals. Learning how to extract these substances from the earth and turn them into all kinds of useful materials was one of the most important developments in human civilization. Spawning tools, jewelry, engines, machines, and giant static constructions like bridges and skyscrapers. Having said that, metal is an almost impossibly broad term that takes in everything from lead, a super heavy metal, and aluminum, a super light one, to mercury, a metal that's normally a liquid, and sodium, a metal soft enough to cut like cheese that fused with chlorine you can sprinkle on your food as salt. What exactly are metals and what makes them so useful? Let's take a closer look. So how can we define a metal? The category of electropositive elements that usually have a shiny surface are generally good conductors of heat and electricity and can be melted or fused, hammered into thin sheets or drawn into wires are known as metals. Let us discuss the properties of metals. Metals have high density. They are lustrous, that is, reflective surface or shiny surface. Metals are good conductors of heat and electricity. They are malleable, that is, can be beaten into thin sheets. And they are ductile, that is, can be drawn into thin wires. And they are sonorous, that is, capable of producing a deep or ringing sound when hit. Metals have high melting point and boiling point. Physical state of most of the metals are solid. Metals like lead have very high density, hence they are commonly used in making of bullets. Metals like gold and silver are highly lustrous. Such precious metals are used in jewelry. Silver and copper are the best conductors of heat and electricity. Aluminium, gold, silver, copper and iron are malleable, that is, can be hammered into thin sheets. Silver and gold are the most ductile metals, that is, they can be drawn into thin wires. Metals are sonorous, that is, they make a ringing sound when hit. That is the reason school bells and temple bells are made of metals. Let us discuss the exceptions in metals. Generally, metals are hard and have very high density, but sodium and potassium are soft metals. They can be cut with a knife and they have very low density. Metals are in solid state, but mercury is the only metal in liquid state. Generally, metals have high melting and boiling point, but gallium and cesium have very low melting point and boiling point. Nonmetals. A nonmetal is defined as a chemical element that mostly lacks the characteristics of a metal. Physically, a nonmetal tends to have a relatively low melting point, boiling point, and density. Let us discuss about the properties of nonmetals. Non-metals are brittle in nature and they are non-lustrous. They are poor conductors of heat and electricity. Non-metals are non-malleable, non-ductile, non-sonorous, and they have very low melting and boiling points. Physical state of non-metals are mostly gaseous. Exceptions in non-metals. Generally, non-metals are brittle in nature, but diamond is the hardest element that naturally occurs on Earth. Diamond is the allotrope of carbon. It has very high melting and boiling point and it is lustrous. Similarly, iodine is also lustrous in nature. Bromine is the only nonmetal in liquid state. Generally, nonmetals are in gaseous state, but carbon, sulfur and phosphorus are the nonmetals in solid state. Nonmetals are poor conductor of electricity, but graphite, one of the allotrope of carbon, is a good conductor of electricity. Let's learn about metalloids. A metalloid is an element that has the properties that are intermediate between those of metals and nonmetals. Metalloids can also be called semi-metals. Let's learn some examples for metalloids. Germanium is a metalloid used in solar panels to increase their efficiency, and also it's used in wide-angle camera lens. Boron is another metalloid used in making bulletproof vest, boron flares, and in the manufacture of fiberglass and heat-resistant glass. The metalloid silicon is used in the manufacturing of microchips, contact lens, rubber bands, ceramics, and kitchenware. The metalloid tellurium is used in the manufacture of rewritable DVDs, glass and ceramic tinting, and copper and stainless steel alloys.